Let's do notes. So we're going to talk about exponential functions for chapter 8. Oh, I look lousy. Okay. 8.1. There we go. Oops. O-N-S. There we go. Exponential functions. Exponential functions are functions of the form y equals a times b to the x, where x and y are the variables, a and b are constants. Constants, that just means they're numbers. Now, from the fast cars thing that you did yesterday, I showed you that the equation for the Miata looked like, and I think I'll put y equals 19,800 times 0.78 to the x, or to the n we actually put. I'll make it an x. So in this case, my a is the 1980, sometimes called the initial value. Usually in word problems, this is the initial value. Or it'll be called the y-intercept. Okay. And the b would be the 0.78 here. And what was that 0.78 in that problem called? That was the multiplier. Okay. So those were exponential functions from yesterday. And we'll do more of them today in the simpler form, a times b to the x, where I won't have such big numbers that you have to deal with. We have exponential functions that increase, that grow, like the Ford Mustang. So we can have a growth function. And those you might see as appreciation or some kind of percentage growth. And those always have your b is greater than 1. And you can have the ones that went down in value, like the Mazda and the Honda, and we're going to call those decay, exponential decay functions. And those would be like depreciation, decreasing, and those will have a b that is between 0 and 1. Okay, so first let's look at an increasing function. So I'll just give it to you in the form of y equals 4 times 2 to the x. And since my b is 2 and my a is 4, my y-intercept is going to be 4, and my multiplier is going to be 2. And since that multiplier b is greater than 1, this one's going to be a growth function. Now we're going to graph it, which will be all the analysis we will do of these. And for what we're doing today, for your graphs, use for x values -2, -1, 0, 1, and 2, and calculate your y's. Remember, order of operation says to do the exponents before you do the multiplication. So let's be real careful when we're doing these. I'm not going to do the negatives first. I'm going to do the positives because they're easier for me to do. So I'm going to start with the 0. So 4 times 2 to the 0 power, I calculate the exponent first. What's 2 to the 0th power? 1. Any number to the 0th power is 1, except for 0, which is undefined. So this is 4 times 1, which is 4. Yeah, and that was my y. That's going to be my y-intercept. When x is 0, I get a 4, just like my a was. Alright, so now I'll calculate when x is 1, 4 times 2 to the first power, that's 8. 4 times 2, now we'll go to the second power, is 4 times 4, which is 16. What would the next number have been if I had asked you for 3 or 4? 32. What's the number after that? How are you getting these? Doubling. All right, let's work backwards. 16, 8, 4. What should the next one up be? 2. All right, let's verify that. 4 times 2 to the -1 power is 4 times 2 to the -1 is the reciprocal of 2 to the first power. So that's 1/2 to the first power. And 4 times 1/2 is 2, just like you told me. What's the next one going to be? All right, let's verify it's going to be 1. This is 4 times 2 to the -2 power, which is 4 times the reciprocal of 2, 1/2, to the +2 power. 1/2 squared is 1 squared, 1, over 2 squared, 4. And what is 4 times a fourth? 1. If I put -3 on here, what would that one have been? 0.5, yeah. And the one after that? 0.25, and so on and so on. Okay, so now when I go to make my graph, let me scale it. I don't have any negative y's. They're going up to 16. My x's are just going from -2 to +2. So 2, 4, 6, 8, 10, 12, 14, 16. Yeah, we'll do that. Alright, when x is -2, y is 1. When x is -1, y is 2. When x is 0, y is 4. When x is 1, y is 8. When x is 2, y is 16. So my curve, let me see what's going to be the easiest way to draw it here, is going to be rising fairly quickly on the right, and on the left it's going to be going down, but it's not going to cross the x-axis. It has what is called an asymptote at the x-axis. It's going to flatten out when it gets towards the x-axis. And all of your exponential growth graphs are going to look